tides. The periodic rise and fall in the level of sea or ocean is called tides. Tides are caused by the force exerted from the gravitational pull of the sun and moon on the Earth's surface. However, the moon is the primary cause of tides. They are also caused by the effect of the rotation of the Earth. The force exerted is directly proportional to the mass of the heavenly body. Tides occur within a period of 12 hours, 25 minutes twice daily. Types of tides. These are different types of tides. The type of tide occurring in the ocean depends on the relative position of the Earth to Moon and the Sun. Their gravitational pull is always varying, causing the different tides. These tides are perigean tides, apogean tides, spring tides, and neap tides. Perigean tides. The tides occur when the moon is nearest the Earth. This results into a high gravitational force and consequent high tides. The apogean tides. The changing distance between the Earth and the moon influences the height of tides. When the moon is farthest from the Earth, the gravitational force is very weak. The resultant tides are called apogean tides and are lower than normal tides. Spring tides. When the sun, moon, and the Earth are in a straight line, the position is referred to as syzygy. At this time, the gravitational forces are very strong. This results in the highest high tides and the lowest low tides. Spring tides occur twice a month at new moon, when the moon is between the sun and the Earth, and at full moon, when the Earth is between the sun and the moon. Neap tides. When the sun, moon, and the Earth form a right angle, this position is referred to as quadrature. The sun and moon exert a gravitational pull on the Earth's surface in opposite directions. This causes high and low tides that are below normal. Waves. A wave is the oscillation of water particles on the surface of the sea. Waves result from the friction between wind and water surface. However, giant waves may be generated by earthquakes, volcanic eruptions, hurricanes, and rock falls at or near the sea. To understand more about waves, you need to learn the wave terminology. The diagram that follows shows part of the wave. The illustration shows different parts of a wave. The top of the wave is referred to as the crest, while the bottom of the wave is the trough. The horizontal distance between the two crests is the wavelength. The vertical difference between the wave crest and trough is the wave height. The height depends on the strength of the wind, the area covered by the waves, that is, the fetch and the depth of the water. The larger the fetch and the depth of the water, the larger the waves. In an open sea, waves are likely to travel far away from where they originate, reaching the shore as swell waves. How waves are formed. When air blows over the surface of the water, frictional drag is exerted on the bottom layer of wind. This frictional drag is passed on into the layers of air above. The different layers of air experience different frictional drags, making them move at different speeds. This makes the air to tumble in a circular motion. This causes the water to take the form of waver. The waves are sustained as long as the winds blow. As the waves approach the shore, the depth decreases as the water is shallow. This causes the decrease in the height of waves, which gradually plunges and breaks. The forward movement of water after a wave is broken is the swash. The back movement due to gravity is the backwash. Types of waves. There are two types of waves, namely constructive waves and destructive waves. Constructive waves help to bring material from the ocean and deposit on the shoreline. Destructive waves are normally high in frequency. The wave's main activity is that of erosion. The rate of erosion depends on the structure of the coastline. Coasts that have well-jointed rocks are easily eroded. Wave action and resultant features. Waves are responsible in shaping the coasts. Erosional work of waves is carried out in 4 ways. These are corrosion, hydraulic action, attrition, and solution. Corrosion. This takes place when the rock fragments are picked up in swash and hurled against the foot of the cliff. Hydraulic action. This takes place in 2 main ways. Compressed air action. When air is thrown against cracks and crevices, it expands. When retreating, it releases pressure explosively, causing the rocks to shatter and fracture. Direct wave force. This happens when there is a great pounding force on rocks caused by waves. Attrition. This occurs when loose fragments hit against the shore and each other. In the process, they break and reduce in size. Solution. The rocks may have minerals that react with seawater as it has carbonic acid in it, for example, limestone rock. This occurs when the cliff face is soluble through a chemical reaction. Resultant features. The erosive action of the waves results into the formation of features such as cliffs, wave-cut platform, cave, blowhole, geo, arches, stacks, and stumps. Cliffs. A cliff is a steep rock face along a coast where land rises very steeply inland. Cliffs are formed by the erosional action of stormy waves. The waves start by cutting a small hollow called a notch. The notch is enlarged and developed into a cliff. The continuous waves activity at its base produces undercutting that lead to the formation of an overhanging cliff. Further attacks on the overhanging cliff cause it to collapse, creating a new cliff face. Examples of cliffs can be observed at Fort Jesus and Aldina Visram High School in Mombasa. Wave-cut platform. Prevalent erosional waves attack the base of the cliff. This wave erosion leads to the formation of a wave-cut bench. Later, the eroded material is swept by breaking waves to form an offshore terrace. Continued wave erosion and weathering lowers the cliff, forming a wave-cut platform. Cave. A cave is a natural cylindrical tunnel which extends into the cliff or into a side of headland following the lines of weakness in the rocks and whose diameter decreases from the entrance. The cave develops from the line of weakness in the rocks. Wave actions such as wave abrasion and hydraulic action acts on the weak areas of the rock on the cliff face. Continued erosion gradually enlarges the hole until it develops into a cave. Blowhole. A blowhole is a vertical passage opening from the landward side cliff to the roof of the underneath cave. Formation. A blowhole is formed when the force of breaking waves puts pressure on weak areas, causing alternating compression and expansion of air. A weak joint is then formed extending from the roof of a cave onto the top of a cliff. With time, the passage is enlarged and opened by weathering and erosion, forming a blowhole. Blowhole. A blowhole is a vertical passage opening from the landward side cliff to the roof of the underneath cave. Geo. A geo is a long, narrow, steep-sided inlet running inland from the edge of a cliff. Formation. During high tide, breaking waves splash and hit against cliff face, causing further erosion along the line of weakness. The roof of the cave eventually collapses and forms a long, narrow inlet. This inlet that is occupied by water is called the geo. Arches, stacks, and stumps. These are features produced by wave erosion. They develop from a headland. Arches are bridges of rock left above openings, eroded in headlands or stacks by waves. Formation. When waves curve round a headland eroding it on both sides, caves are formed. Caves develop on both sides of midland joining up to form a passage. Such a bridged natural opening is called an arch. A stack. A stack is a steep pillar rock rising from the sea, formerly part of the land. A stack is derived from an arch. Continued wave erosion on an arch at high water tide results into the collapsing of the arch's roof. When this happens, a pillar of rock is left standing some distance on the seaward side of the cliff line. The pillar of rock which is left standing on the seaward of the cliff line is called a stack. It is usually wider at the top and narrower towards the bottom. A stump. Prevailing wave erosion may still act on existing stack, reducing its height gradually. During high tide, the stump is submerged, while at low tide it becomes visible. This remnant of the stack is called a stump. Transportation and deposition action of waves. Apart from the erosional work of the waves, there is also the transportation action of waves. Waves, as agents of transportation, are responsible of moving materials over a long distance along the coast. The material consists of pebbles, shingles, sand, and mud that is derived from landslides on cliffs and rivers entering the sea. If the waves break in a slighting position to the shore, the swash moves in a sloping direction while the backwash rushes them back at right angles on the shore. These two actions result in the movement known as the longshore drift. The longshore drift does not transport materials indefinitely. The materials become heavy and are deposited along the shore. Deposition of material is influenced by four main factors. These are energy and frequency of breaking waves, gradient of the shore, shape of the coastline, and depth of the sea. Energy of breaking waves. For the deposition to take place, the breaking waves must have a strong swash and a weak backwash. Such waves are called constructive waves. The backwash effect makes the excessive load to be left behind the shore. Waves should also break at a low frequency to allow materials to settle. Gradient of the shore. A shore with a gentle gradient reduces the velocity of the backwash, causing the wave to deposit its load. Shape of the coastline. This is the orientation of the coastline in relation to the path of the prevailing winds and advancing waves. When the coastline changes abruptly and turns inwards towards the land, the action of longshore drift is reduced. This leads to the deposition of material along the shore. Depth of the water. Deposition of materials is predominant in shallow waters. This is where the circular motion of waves is broken as waves come into contact with the ocean floor. Features resulting from wave deposition. The deposition action of the waves results into the formation of features such as beaches, spits, sandbars, tombolos, carpet forelands, mudflats, salt marshes, and coastal dunes. A beach is a gently sloping accumulation of materials like sand, boulder, and coral fragments along the coast. The accumulation of this material is between the low and high tide level. Beaches are formed by constructive waves. This results in the accumulation of materials at the shore. During storms, the destructive waves that occur destroy beaches, creating other minor features. This modifies the profile of a beach. They include beach ridges, beach cusps, berm, and beach rock shells. Beach ridges. Beach ridges are a long, narrow depression on a beach that separate two ridges. They are constructed by breaking waves. They are mainly made of coarse sand boulders and shingle deposited along a regular coast. They develop on the foreshore of a beach and can be seen only when the tide is low. Examples are Diani and Shelly beaches. Beach cusps. Beach cusps are projections of sand and shingles alternating with rounded depressions along the beach. The projections are usually of open cone-shaped apexes pointing seaward, giving a kind of scalloped pattern. The eddying swash erodes the depression, moving coastal material on either side onto the cusps. They are progressively enlarged. Berms. Berms are wave-deposited sediment platforms that are flat or slope slightly landward. It is therefore a ridge or bench with a steep front that develops during a high tidal range. Beach rock shells. It is composed of sand, shells, and pebbles which have been cemented together by calcium carbonate forming projections above the sand. A beach is a gently sloping accumulation of materials like sand, boulder, and coral fragments along the coast. The accumulation of this material is between the low and high tide level. Beaches are formed by constructive waves. This results in the accumulation of materials at the shore. During storms, the destructive waves that occur destroy beaches, creating other minor features. This modifies the profile of a beach. They include beach ridges, beach cusps, berm, and beach rock shells. Beach ridges. Beach ridges are spits. A spit is a low-lying narrow ridge of sand, shingle, or pebble with one end attached to the coast and the other end projecting into the sea. It is therefore an elongated ridge of sand that projects from the land into the mouth of an adjacent bay. Spits develop when the movement of material by the along-shore drift is halted by shallow waters or protruding headland. Over time, the material builds up through the process of deposition. The accumulation of deposited material may continue growing towards the sea, forming a hook-like feature that is at the end of the strip called a spit. Their ends are curved by the action of waves coming from different directions. Sandbars. A sandbar is a ridge of material, usually sand, shingles, and mud deposited in the shallow water which lies offshore parallel or almost parallel to the coast. There are two main types of sandbars, namely bay bars and offshore bars. Bay bars. A bay bar forms when a spit grows completely across a bay, harbor, or sea inlet. It encloses a portion of waterland ward side to form a lagoon. It starts off as a spit which develops right across the entry of the sea inlet, forming a barrier. Offshore bars. An offshore bar forms a very shallow, gently sloping seabed coast which extends far out into the sea. This occurs when the sea waves are forced to break offshore due to shallowness of the water, thus depositing material off the coast. The deposition and accumulation of material where the waves are breaking form a breakpoint bar, which is a ridge running parallel to the shore. This barrier is the offshore bar. The section of the sea water that is between the land and this bar forms a lagoon. Tombolo. A tombolo is a bar of sand or shingle linking an island with the mainland. It starts as a spit, then grows out into the sea until it joins an offshore island. A tombolo can be seen at Ngomeni, north of Malindi. Cuspate forelands. A cuspate foreland is a broadly triangular-shaped deposit of shingle or sand projecting into the sea. A cuspate